Welcome to the Foundry by Forge College. Today's explainer is all about testing and debugging workflows. Imagine your brand new Solana Web 3.js capstone project is a high-performance physical machine. We've spent time wiring the gears, getting everything hooked up, but today we're literally drafting the blueprints to stress test this engine before it ever hits the factory floor. I mean, nobody wants the steering wheel to just pop off on the highway, right? So we're going to treat your app like a physical machine to make absolutely sure it won't break when real users finally get their hands on it. Let's take a look at our engineering schematic for today. We've got 6 exact steps to build a foolproof testing engine. First, understanding where we stand right now. Second, building our testing harness. Third, running our core integration tests. Fourth, opening up that debugging toolkit. Fifth, crafting the final debug report. And finally, making sure we're actually ready for deployment. So let's jump right into section 1, where we stand now, going from fragile to bulletproof. If you recall, in our previous lesson, implementing core features and integration, we successfully wired up the application. We connected our React client straight to an on-chain program. But right now, honestly, our app is pretty fragile. Sure, it's fully wired up, but it's totally untested. That means it is highly vulnerable to regressions and lurking bugs. It's basically a beautiful, highly complex digital house of cards just waiting for a strong breeze. We've got to transition from this fragile state to a bulletproof one. By the end of this explainer, you want an app with validated end-to-end flows, properly documented fixes, and a system that is undeniably ready for a reliable deployment. Moving on to section 2, building the testing harness. We like to call this the wind tunnel. Okay, we need to bust some jargon right off the bat. Deterministic is our ultimate goal here. Deterministic tests are tests that behave the exact same way every single time. They rely on completely fresh, seeded environments rather than some messy shared state. Think of it this way. We want standardized crash test dummies. If our dummy reacts differently every single time we hit the wall because of leftover damage from a previous test, well, we learn absolutely nothing. We want predictable, repeatable, standard conditions every single time.
Here's the actual assembly manual for our harness to ensure we start totally clean. Step 1, start our local test validator using the provided shell script. Step 2, load up our seeded accounts and fixtures so we aren't starting from absolute zero. Step 3, initialize our test-env.js helper. And step 4, this is crucial, airdrop some SOL to a completely fresh keypair. This exact routine ensures we start with a clean local validator and a freshly funded wallet for every single test run. No ghost data, no flaky, unpredictable results. Just clean science.
All right, section 3, running core integration tests. This is the stress test. So check out our core testing matrix. We're mapping our exact code files directly to the mechanical flows and the safety assertions we are actively testing. Looking at the first row, we have wallet-auth-test.js. This specifically tests the wallet connect and sign flow, asserting that the program instruction succeeds and emits the expected event. Next down is mint-transfer-test.js, which handles token minting, verifying the recipient's balance actually increases by the exact expected amount of lamports. And then for the grand finale, client-sync-test.js. This is our end-to-end flow. It ensures that the client-side UI state perfectly matches the actual on-chain reality. Now keep this in mind. We aren't just testing random parts in isolated vacuums. True integration tests must mirror real client behavior. We are interacting from the client, routing straight through the API and going all the way down to the Solana program. We are sending our automated crash test dummy through the exact same digital paths and API endpoints that a real human user is going to take. Section 4, the debugging toolkit. Let's go find some gremlins. When a test inevitably fails and your console turns angry red, don't panic. Just take a breath and use these 5 diagnostic practices. First, isolate the failing assertion to find the exact line of code that's breaking. Second, run only that failing test alone, but with verbose logging turned on. Third, add temporary assertions or console traces. Basically leave a little trail of breadcrumbs through your code. Fourth, try to reproduce the bug with a minimal node script or the Solana CLI to see if the UI is actually the culprit. And fifth, craft a minimal failing reproduction block. This isolates exactly which screw is loose without you getting totally lost in the entire engine block. The absolute crucial rule of thumb here is this. Prioritize small, reversible fixes and add regression tests to prevent recurrence. When you find a bug, please do not rewrite the entire file in a frenzy. Apply the smallest possible patch. For example, maybe you just forgot to await your latest block hash before sending a transaction. Fix just that one thing, and then write a regression test so that specific block hash gremlin never ever comes back to haunt your machinery. Moving right along to Section 5, crafting the debug report, the final case file. Listen, a debug report isn't just busy work to annoy you, it is both an engineering deliverable and a really vital decision artifact. It clearly explains which bugs were successfully squashed, which minor quirks might still remain, and the exact mitigations you applied. Think of it as the official schematic that gives your code reviewers a clear, highly readable path to validate your hard work without having to guess. If you're ever staring at a blank screen, completely stuck on what goes into this markdown file, just follow this simple checklist. You need the failing test name and the timestamp. You need to paste in the captured standard output, standard error, and the validator logs. You absolutely must provide clear reproduction steps. Then, show your proposed fix and the git patch def, because trust me, reviewers love a clean git def. Finally, show off the new passing test output. Follow this, and your engineering case file will be completely flawless. Remember, great documentation is half of great engineering. And finally, Section 6, ready for final deployment, waiting for the green light. Before you even think about moving on to our next lesson on deployment, you must pass these 4 gates. Gate 1, ensure all critical core tests pass perfectly on your local machine. Gate 2, finalize your debug report artifact. Gate 3, document a clear rollback or mitigation strategy, because hey, even the absolute best engineers need a reliable eject button, just in case. And Gate 4, verify that your continuous integration pipeline runs smoothly and non-interactively. By passing these gates, you're turning fragile manual checks into automated, highly reliable guards. So ask yourself this question before you launch. Are your critical flows truly reliable, reproducible, and strictly guarded by automated regression checks? Don't hit that launch button until you can confidently say yes to all 3. When you're ready to learn more about deployment and take the next big step, be sure to visit forge.college to continue your Web3 journey with us. Keep building, keep testing, and I'll catch you in the next explainer.